recording? Again, good morning, grade 7. We are
Morning, sir.
Morning.
on our topic. Okay, we are done with filtration, correct? Let's move now to
I don't think
evaporation.
so. Anyways, evaporation isn't like about water.
Are we done with filtration?
No,
Diba, I discussed yesterday how to separate sugar.
sir, not yesterday.
The last
There's no class.
discussion, the last discussion, rather.
I think we were
I
talking
don't
about
remember.
homogeneous and
You're
what do
absent
you-
last meeting, Travis.
No, I wasn't.
Let me check on this.
We were talking about homogeneous.
So there you go. You separated sugar. And okay. Let's have the review. Let's
Okay.
do that. Mechanical separation. Okay, suppose you have a mixture of chocolate chips and cereals, and you want to separate them.
I wasn't talking.
If the mixture are large enough, they are large enough, it is easy to separate them manually by picking. Can you hear actually now? Mechanical separation. Can you see the shared screen? Meaning to say that you need to manually
Yes.
remove them or manually separate them. Right? So how about this one, Travis? Filtration. Okay.
Ah.
Okay. Again?
Okay, I remember now. I remember now. I remember.
So, filtration, start by identifying properties or property of a sugar the sun does not have. Okay. In filtration, you may say that the sugar dissolves in water and sun does not. It cannot. Actually, it does. All you need is a filter through which the solution will pass, leaving behind sun. So we are done with filtration, correct?
Yes, I just forgot.
Yes.
Okay. Again, filtration. Let's have this again. Let me share my screen. Again, filtration is a separation of different properties. Okay, these are separation of different components with different properties. Like for example, the sand and the sugar. Now you can actually separate the sand and the sugar by filtration. How? You need to dissolve the sugar because sugar can be dissolved in water. Okay, leaving behind your sand. Now your sand, you can use the filter. Please turn on your camera. Everybody? Are you still with me?
Yes.
Okay.
Yes.
Please turn on your camera. So that is infiltration, right? Let's move now to evaporation. If you put seawater in an open container and leave it with a mixture under the sun, the water evaporates in the process called solar evaporation because we're using the heat of the sun or solar, leaving salt particles behind. This is how we actually create what? This is how we create
Salt.
salt, correct. This is how salt is actually created. Okay, please turn on your camera again. Wait. Okay. What are other things we can actually use with evaporation or maximize with evaporation is that we can also use evaporation in the process of separating sugar and
Liquid.
water. Yeah. What else? How about creating a or separating the other mixture with evaporation? Like for instance, creating a honeycomb. Okay, the one being used in the movie or in the series of Squid Game. They're creating honeycomb there. They're using evaporation in the process. They melted, okay, the sugar in the water, leave it behind, and enable the water to evaporation to evaporate water and leaving behind sugar in the process. Now you're creating honeycomb. Distillation. Okay, the best way to separate components of a mixture composed of two liquids, again, the best way to separate components of a mixture composed of two liquids with different boiling points is through distillation. Okay, the liquid with the lowest boiling point is collected first by using evaporation and condensation, and the other component with the higher boiling point will be collected next using the same process. By the way, where is your camera again? Everybody.
Your cameras are on.
Right. How about others?
No, like
I have it on.
everyone's
Please
is
turn
on
on your
except for
camera
Kaiser's.
again. Let me share my screen again. Okay. Again, in the process of distillation, like for instance, the creation of your wine. Okay, the creation of your distilled wines, your drinks. Okay, this is how they created your drinks. And even in your lambanog, are you familiar with the lambanog? Lambanog is
No.
actually
No.
generated or originated in the Philippines. Okay, they use distillation in the process to separate alcohol in the water, in the mixture of alcohol and water. Okay. Paper chromatography. Okay. Homogeneous mixtures. Okay. Homo means one. Homogeneous mixtures that are composed of solvent and one or more solutes, or the one being dissolved in the solvent, are often separated by chromatography. Okay. In chromatography, various materials of a mixture are selectively absorbed in a column or strip paper. Okay. The components then are then separated on the surface such as the paper. Okay. Paper chromatography in the Philippines is not common. Okay, but there are a lot of laboratories here is using paper chromatography as of the moment. Okay. Paper chromatography is used to separate the components of ink and food dye. Okay. It consists of stationary phase, a solid like absorbent paper, or a liquid, and a mobile phase, a liquid or gas, which flows to the stationary phase and carries the mixture with it. Okay, this is how your processed foods are actually being done. They're using paper chromatography in the process. Okay,
I don't understand.
do they know? Vaccines are different. Okay, vaccines are different. Centrifugation. Okay, if you have questions, please raise it directly, right? Everybody? Centrifugation is the process involves spinning of container in a circle at a high speed, just like separation. Okay, the separation of the components of your blood in CBC. They're using centrifugation in the process. Okay, the centripetal force, the force of an object moving in circular path that develops during this rotation, allows the denser substance to settle at the bottom of the container. Okay. Again, just like when you have your CBC, okay, they actually collected blood samples in you and put it in a centrifuge. Okay. A centrifuge creates now a centripetal force, okay, which allows the denser substance to settle at the bottom for them to check on it. That is how they done the CBC. Okay. Applications of separation techniques in food processing, because homogeneous mixtures, if you're going to think about the whole sequence of a pie or the whole pie with regards to homogeneous mixtures and heterogeneous, we are talking about food separation. One is the physical separation. This is one application of homogeneous mixtures and heterogeneous mixtures. Some machines sort out fruits, nuts in different sizes and texture and help them grading or labeling the product. Okay, this is common. Other can remove waste from food products. For example, there is a device that pulls husk off ears of corn and an equipment that removes feathers from chickens before they are butchered. Okay, that is physical separation. You can actually see it directly. Okay, physically, you can separate it physically. But other means, like if you're going to separate liquids, this is the technique that separates vegetable oils, again, from other liquid products, or clarifies beverages or beverage that has developed a cloudy appearance because of the dissolved solids. So they usually use centrifugation. Okay, like for example, if you're going to make, again, like for example, your beers, okay? Your beers are the product of centrifugation. Okay, they usually get the other solutes, okay, and separate it with the product itself that is actually under centrifugation. How about with the solution? Okay, let's move now to a solution. A solution is a homogeneous mixture consists of solute and solvent, correct? Technically, if you're going to look at solvent, it is usually in a larger amount, okay, because it is the one being, or it is the one that dissolves the solute in a solution. Okay, a solute determines a larger amount than solute and determines the state of a solution. There are a lot of states of a solution. Okay, let's take a look at it later. Another way to describe a solution is in terms of the substance dissolving in another substance. Okay, a solute is a component that dissolves in a solvent. Let's make it more precise. If you're going to look at solvent, it is the one that dissolves, the dissolving agent in a solution. But if you're going to look at solvent or solute rather, it is the one being dissolved. Okay, again, solvent is the dissolving agent. Okay, solute is the one being dissolved in a solution. Right? Question so far as of the moment?
None.
No.
All right. Oh, by the way, um, congratulations everyone for the job well done last science month. I really appreciate it. Okay. Again, do not be discouraged because those are just your stepping stones. Do not rush things over. Okay. You will learn little by little. My piece of advice is I want you to remember all the lessons, familiarize all the lessons. Okay. Because in familiarization, you will actually get a lot of knowledge, stock knowledge in your long-term memories. Okay? Again, do not be discouraged. Those are just stepping stones. Okay? You may not know that before, you may not know the topic today, but eventually you will know the topic later. Right, everybody? Okay, RJ,
Yes.
Travis, and the rest?
Yes.
Okay. Let's go back to the lesson proper. All gases can be dissolved. Okay, recall the composition of air. Remember, your air is a mixture of gases. It consists of about 18 gases in different proportions. Okay, some industrial waste are gaseous solutions like sulfur dioxide, hydrogen sulfide, nitrogen dioxide, okay, carbon dioxide, and carbon monoxide. So remember that your gases are mixtures of different gases, or your air is a mixture of different gases. Okay. Generally, a solution is a liquid because this is the most common form. Solutions in the biological system, okay, take note, and in the environmental or environment are in liquid form. Again, solutions in the biological systems, even in the systems of your body, solutions like are in liquid form, even in the environment. Okay, solutions like ethanol, in which water is in the solvent and the ethanol or ethyl alcohol is the solute. Just like your rubbing alcohol. Your rubbing alcohol are two different kinds. Okay, we have ethanol or ethyl alcohol and isopropyl. Okay? It is actually 70% solution. Okay? 70% alcohol and 30% water. So it is now 70% alcohol or 70% solution. Why do we need to put water in the alcohol? Because if it is 100% alcohol, it will eventually evaporate and it will not do something in your skin or in your application. Again, this is a disinfectant, meaning to say it needs to stay for around seconds or minute in your skin in order to take effect. Correct? In order to do that, we need to put water on it to prevent evaporation process. Remember that your ethanol evaporates around seconds. The 100%, it evaporates around seconds. We have a lot of it in the laboratory. The pure 100% ethyl alcohol and isopropyl alcohol. Again, solutions like ethanol or ethyl alcohol in which water is the solvent and the ethanol is the solute, okay, are called aqueous solutions. Okay, ethanol is a component of perfume, okay, printing ink and glue, okay, and of course your rubbing alcohol. Okay, it is actually composed of ethanol and isopropyl alcohol. Right? Solid solutions have numerous applications. Okay? Like in alloy, a mixture of elements that have overall metallic character is an example of a solid-solid solution. Okay? Solid-solid solution. Your aluminum alloy and your what? Aluminum and iron. So those are solid-solid solutions. Steel and brass, those are solid-solid. We have numerous applications in the industry and constructions or construction. Steel and brass, they usually use this one in your cabling. Okay, it is made of steel and brass. What else? In your wires, these are steel and brass. Okay, the term soluble, okay, is a qualitative description of substances that have the ability to be dissolved in a significant amount in a given solvent. Soluble, it can be dissolved. Okay. Terms like soluble, moderately soluble, and insoluble are used to describe compounds in relation to the given solvent. Like for example, oil is insoluble with water. You cannot actually mix or dissolve oil in water. But sugar is soluble in water. Okay. Or salt. Salt can be dissolved in water. Okay. Salt is soluble in water, but it is insoluble, or you cannot dissolve salt in oil. Insoluble in oil. Okay. Again, salt can be dissolved, or it is soluble in water, but it cannot be dissolved or insoluble with oil. So those are some of the examples. For example, sodium chloride is soluble in water, but again, insoluble in oil. So those are just few. Miscible. Okay. What is miscible, by the way? Miscible is another qualitative term. It is used to describe the solubility of a substance in a liquid and gas-to-gas systems. Like for example, ethanol and water are completely miscible. They are miscible because they can completely mix. While oil and water are immiscible. They are immiscible, meaning they cannot be mixed. Okay? These are the terms being used in the solution, all right? To describe a solution completely, we need to identify not only its components, but also its concentration gradient or concentration. okay, which refers to the relative amount of the component, the concentration of your solute and your solvent. Okay. Unsaturated, saturated, and supersaturated solutions. What are those? All right. A saturated solution is one in which the maximum amount of solute has been dissolved in a given amount of solvent. If you have given the solvent and you dissolve the maximum amount of solute in that particular solvent at a given temperature, and where any more solute added will settle at the bottom, meaning to say there's no space left behind for those added solute. Tendency is it is a saturated solution. It is already saturated. It is already full. Okay, the space there in the solvent is already full with that particular solute. Okay, so if you're going to add another solute there, tendency is it will not mix with water, but rather what stays at the bottom because there's no space for the solute to be absorbed. Okay, that is saturated solution. How about a solution that contains less than the maximum amount of solute that can be held is unsaturated. If it is less than, like for example, if you're going to dissolve less salt in water, okay, that's unsaturated. Okay, again, a solution that contains less than the maximum amount of solute is called unsaturated. In some cases, you prepare a solution containing more solute than it would normally contain. The solution is called supersaturated. So if you're going to mix a lot of sugar, for example, in water, you're creating a supersaturated solution or sugar solution. You can actually prepare this by increasing the temperature, okay, to dissolve the excess solute and slowly cooling the solution. Okay, the supersaturated solution is an unstable condition. Now, if you add acid or crystal on the top of the container, the excess solute will readily crystallize, leaving the saturated solution. Okay, so if you're going to prepare a supersaturated solution, you need to heat up the liquid and add the solute on it. Okay, once it cools down, it will actually leave some crystals behind. Okay, it will actually leave some crystals behind. Why? Because you are creating a supersaturated solution. It will become sticky. Tendency is there are a lot of solutes in that particular solvent. Again, when you're talking about saturated solution, okay, you tend to occupy all the spaces in the solvent. Okay, now if you add more solvent in a saturated solution, tendency is it will actually settle at the bottom because the spaces there in the solvent is already full. How about unsaturated solution? When you're talking about unsaturated solution, you have less solute than solvent. So you're putting less solute in that particular solvent. You're now creating unsaturated solution. How about supersaturated solution? You heat up the liquid and add more solutes on it. Okay? Once it cools down, you can actually create what? A crystal behind, if in case. Or you make the solution very sticky because you're forcing those to go to the solvent, leaving behind a sticky solution that is actually supersaturated. Okay, you can do this by increasing the temperature of the liquid and mix it with the solute. Okay, supposed to be we'll be doing an experiment with regards to this, but this is online. You can only do that in face to face, and I will not require you to do that at home also because it's dangerous, right? percentage composition. Okay. Percentage composition is one way to describe a mixture quantitatively. If we can describe a composition or a solution in a qualitative way, the saturated, unsaturated, and supersaturated, we can also describe a solution in a quantitative way. Okay. One way to describe a mixture in quantitative way is to report its percentage by mass or percentage by volume with this formula. Okay. Percentage by mass is equal to the mass of the solute. You can actually do this in the laboratory, supposed to be, over the mass of the solution. Okay. Or is equal to the mass of the solute times 100 over the mass of solute plus mass of solvent. Again, how can we get percentage by mass? This is percentage by mass is equal to mass of solute times 100 over the mass solution. Take note that your mass solution is composed of solute and solvent, correct? Okay. Now it's equal to the mass of solute times 100 over the mass of solute plus the mass of solvent. Okay, di ba? Your mass solution is composed of solute and solvent. So it's the same. Okay? Or we can actually use the percentage by volume. Okay? By volume of the solute, okay, times 100 over the volume of solution. Okay? Which is the volume of solute and the volume of solvent. Volume of solute plus volume of solvent. Uy, what are you doing in the chat box? Again, we can actually describe a particular solution through percentage composition. Okay? This is in a quantitative way. Again, the saturation, those are in the qualitative way. But this is in the quantitative way. Take note because this will come out in the exam. I am sure. I will let you compare how can we describe a solution in a quantitative way and in a qualitative way. I'm pretty sure it will come out in the exam. Okay. Again, for the quantitative way, we have percentage by mass, which is mass of the solute times 100 over the mass of the solution, or in the volume, the percentage by volume, that's volume of the solute times 100 over the volume of the solution. And there you go. You can get the percentage by volume. Okay. Applications of percentage composition. A saline solution is a solution of sodium chloride in sterile water. Are you familiar with your saline solution? Have you heard about saline solution?
No,
No.
I never heard of it.
Not yet? Okay. But have you heard about
Explain.
dextrose?
No, yes.
Okay.
Yes.
Isn't that like
When you
a injection thing?
when you
Yeah.
are actually hospitalized, okay, and the doctor and the nurse put a dextrose on you, your
That happened to
dextrose
me.
is called the NSS or the natural saline solution. It is actually a saline solution inserted in your veins. Okay?
But teacher, is it really necessary to put it like over here?
Yes, it is necessary. If in case your take note that your veins, some of your veins are collapsing already, especially if they cannot actually see it. Okay? That's why they need to look for another alternative. Where can they actually inject or where can they insert the IV, intravenous? Okay,
Oh.
intravenous.
Pero,
Okay.
pero teacher, what if
started
they
the
would accidentally hit the vines for our life?
Okay, if they accidentally hit the wrong veins, it will just create a hematoma. It will just create a black portion in the area. That's
My
that is called
sister,
hematoma.
teacher, my sister went through that about 3 times.
Okay,
The
and then
doctor ka ng dextrose ba? And sayop ang naigo.
sometimes yes, especially if the blood vessel there is collapsed already. So most probably yes, but we need to consider also that these doctors and nurses are not perfect at all. Okay, they cannot actually see it directly because their eyes are just like ours. Okay, that is why they're actually thinking about where can they place it um, in a perfect area of placement. They're thinking about that also. Okay, they look for alternative area for placement. Again, your NSS, it is a natural saline solution found in your dextrose. It's a solution of sodium chloride, salt, and a sterile water. Sterile meaning to say it's clean, untouched. Okay, a normal saline solution or NSS is 0.9% sodium chloride. It has salt in it or ions. It is ions. It is used as an intravenous or IV infusion for patients who have become severely dehydrated. Okay? It also prevents dehydration for those who cannot consume liquids and nutrients by mouth. Okay? It prevents dehydration because it is 0.9% sodium chloride or ions. It contains ions. Right? Alcohol by volume, abbreviated with or as ABV. Okay? As measured on how alcohol in your drinks, okay? How many alcohol are actually in your drinks? Is it 9%? Is it 5%? So those are percentage composition. Okay? Is contained in the beverages or beverage. Right? Let's move now to elements. Do you have any questions so far with
No question.
percentage composition? Those are
No,
few
sir.
of the percentage composition, right? Again, in medical field, there are a lot of percentage compositions there. Okay? Because, like for example, in your NSS, okay, it needs to be exactly needed by the body, or else you might get a wrong effect in the body. Instead of rehydrating the body, if there are more salt there, it can cause dehydration in the body. That is actually um the effect of those over the solutes or over percentage composition. Elements. Okay. When a mixture is completely separated using different separation techniques, the resulting components are said to be purified. Okay. The purified components exhibit the same properties throughout and are homogeneous. Okay. They are homogeneous already. These purified components are referred to as pure substances. Okay. Which include the elements and compounds. Okay, what are the two pure substances? We have elements and compounds. How do we know if it is an element and how do we know if it is a compound? Let's take a look at this. Okay, pure substances exhibits the following characteristic properties. Number one, it cannot be separated into two or more substances by physical or mechanical ways or means. Okay, number two, it should be a homogeneous or a uniform properties throughout the sample. It should be homogeneous. And number three, it has a constant chemical composition. If it is has a constant chemical composition, like for example your salt, your sodium chloride, NaCl, or your sugar, which is your glucose, which is C6H12O6, it is considered as a pure substance. Okay? Aluminum is an example of a pure substance that is an element. Okay? Gold, silver, platinum, oxygen, nitrogen, carbon are the examples of elements found in your periodic table. Okay? Can you chemically reduce elements into simpler substance? The answer there is big no. Okay? Operationally, an element is defined as a pure substance that cannot be chemically decomposed or chemically changed or chemically separated. So that is an element. If you cannot chemically separate that, it is considered as an element. Like for example, you cannot actually chemically decompose oxygen. Can you separate oxygen? No. Can you separate carbon? No. Can you
No.
separate hydrogen? No. Because they are considered as elements. Again, elements are defined as pure substance that cannot chemically